Hello everyone, today's video is about the reactance of capacitors and inductors. So to first understand reactance, we need to understand that it is part of a greater concept called impedance. Now, impedance is a measure of how current flow is opposed in AC circuits. Much like a resistor has a resistive property which resists current flow, in an AC circuit, capacitors and inductors can also resist the alternating current flow from the voltage source. This is what is described by the term reactance. Now when we calculate reactance, there are three factors that we need to consider. These are inductance, capacitance, and frequency. The reactance of a capacitor, denoted as Xc, is equal to 1 over 2 pi frequency times capacitance. The capacitance is measured in the unit farads, and frequency refers to the frequency that is delivered by the AC source. It's also important to note that for both capacitors and inductors, the unit of measurement for reactance is ohms. Now the reactance of the inductor, denoted as XL, is equal to 2 pi frequency times inductance, where inductance L is in the units of henries, and frequency is the frequency delivered by the AC source. Now the major characteristics of these two formulas are given by how they're mathematically composed. If we look at the reactance of the capacitor, we can realize that it's an inverse function, so as F increases, reactance will exponentially decrease. Now if we look at the reactance of the inductor, it is a linear relationship. So there will be a linear increase with the increase of frequency. Now this is how we describe certain AC circuits. When the frequency is low, the capacitive reactance is higher, so the circuit is capacitive. So at higher frequencies, the reactive inductance is higher and the circuit is inductive. Well now, what is the significance of knowing reactance? What does it tell us? Well, apart from how an inductor or capacitor resists AC current, it can give us the phase shift of the current, which allows us to identify whether a circuit is capacitive or inductive. Now, if you were to run through your memory to the start of the video when we mentioned impedance, this is important to know. When using the total impedance formula, which is provided here, you can convert to polar, which then gives you an angle. Now knowing that inductance is generally going to shift the current back by negative 90 degrees, then we know that a negative angle means that the circuit is capacitive and vice versa.